Welcome to Brain Vision.
24 states that you are walking to your physics class at speed 1 meter per second with respect to the ground. Your friend leaves 2 minutes after you and is walking at speed 1.3 meters per second in the same direction. There's multiple questions. The first one says, how fast is she walking with respect to you? So we'll just do that one first. So how fast is she walking? So in the objects that I labeled here, V1 is your speed, V2 is your friend's speed. So anytime I use 1 as a variable, naming convention, that's you, and 2 is your friend. So her speed with respect to you is simply just her velocity minus your velocity. 1.3 minus 1 is 0.3 meters per second. Right, so that's the difference. The two sig figs should be 0.30. But we can just leave it as 0.3 because that's our difference. And we can state that we can put an uncertainty on that, 0.3 plus or minus 0.1 meters per second. The second question says, how far does your friend travel before she catches up with you? So in order to figure that out, we need to figure out how far you go in the first 2 minutes, because you have a 2-minute head start over your friend. So we can say the displacement that you have in the first 2 minutes. So the section here is the 2 minutes, from 0 to 2 minutes. So if you're starting at the same position, your position is just your distance per time, your velocity times the time you have, which is 2 minutes or 120 seconds. So in these first 2 minutes, you go 120 meters, where your friend x2 travels nowhere, 0 meters. So maybe we'll say this is initial, comma, I initial. So 2 minutes onward, so after 2 minutes, so after 2 minutes, both of your position versus time, so your position as a function of time is 120 meters, and you're still traveling at the same rate, 1 meter per second times time. And your friend has no head start, so their initial displacement is 0 again, but they are traveling at the velocity of 1.3 meters per second. So we're going to find where we meet up. So if we go up here now, we meet up when x1 of t equals x2 of t. Right, your displacements are equal. So if we set these values equal to each other, 120 plus 1t, that equals 1.3t. Oh, sorry, I guess down here for my equation 2, I forgot the time, of course, where we have 1.3t. So we can rearrange this such that t equals 120 over 0.3, again, just by rearranging our values, and we find that the amount of time to catch up is simply 400 seconds. But if you double check our question, it states that we want to know how far you travel, not the time at which you travel. So we can use, now that we have the time, we can use either one of these equations to figure out how far you travel, because it will give the same answer. So let's use x2, your friend's speed, or your friend's displacement, sorry. We have 1.3 times 400 seconds, which is 520 meters. Great. Finally, it does indicate the uncertainty, which we'll do in a second, and any assumptions you made. Any assumptions are just, you and your friend are both traveling at constant velocity, even though they're different velocities. There's no objects or, students in the way. So no one's blocking either of your paths, and of course the hallway is long enough, or wherever you're walking is long enough to accommodate 500 meters. Things like that would be appropriate assumptions to make. So really, the object which we want to look at in terms of providing uncertainty would primarily be with this term here, our denominator, this 0.3 with our velocity, 0.3 meters per second in our velocity. So if we can perform this calculation with this uncertainty, where I guess I did mention this before and I erased it for some reason. Really, this should be two sig figs, right? Two significant digits. We're starting with 1.0 as given in the question and 1.3 as given in the question. So my final answer should have two significant digits. My apologies for that. So far, that has not affected our answer, but it will affect what we provide for an uncertainty here, right? Because this 0.3 is the same difference in velocities that we have shown here. So if we have these two velocities, our two times, so time low is 120. If we have the negative error term, so 0.29 divided by 0.29 finds that our time required for this to occur is 400 and I'll round up to 414 seconds. Where our time high, our larger value for the velocity, so 0.31, simply 387 seconds. So the difference is about 14 seconds either way. So if we use both of these values to compute x2 or the distance in general, x1 equals x2. So I'll just in this scenario, really, our total displacement, we can use 0.3, or use these two different values for time, and we find that if we use our low time value, or our low velocity error, the range of potential values is simply, I'm just calculating it now. We have a range, a low value of 503 meters and a high value of 538 meters. The difference is about 18 meters, we notice from our original value. So we can say our final displacement that both of these people go, you and your friend, are 520 meters. Again, that's two significant digits, plus or minus 18 meters, 17 or 18 meters, but it's about the same. So right, there you go. So again, my apologies, again, didn't affect the rest of the problem, but we should have two significant digits here. Our uncertainty is the last digit of that item. We can use that to compute the different times using those different velocities. And we find the range of distances produced is about 18 meters.